vertical circle. In one, object was free to leave the vertical circle, and in another, object was not allowed to leave the vertical circle. So when object was not allowed to leave the vertical circle, it was when it was connected to a rod, and when object was allowed to leave the vertical circle, it was when it was connected to a string. Okay, so let us see. Okay, okay. Okay, so everyone please pay attention. You need to draw 6 circles. This is A, this is B. Now let me show you. In A, this is a string and this is mass M. String. Okay. In B, it's a mass which is kept inside a hollow sphere. Okay. This is hollow sphere and this is mass M. This is C, this is D, this is E. Okay. Now in C part, it is connected to a rod. It is connected to a rod. In D part, basically it is a bead in a wire. This is wire frame and this is a bead. This is mass M, this is mass M. All of the objects have mass M. Okay. In E part, actually we need to create one more circle. Yeah. Consider both as circular. If you are finding that it is not perfectly circle, it's fine. Basically it is. So it's a pipe actually, and in which a ball of mass M is there. Okay, so this is a pipe. All right. So please draw these 5 diagrams. Please draw these 5 diagrams, all of you. Okay, I hope you all have noted. Now pay attention. In 1 and 2 or A and B, in I am removing this. Okay. In A and B, object is free to leave the vertical circle. Object is free to leave the vertical circle. Okay. So basically A and B are identical. Basically A and B are similar. Okay. Similar means as object is free to leave the vertical circle, so A and B are almost similar. Now V at A minimum to complete vertical circle is root 5 GR. Okay. T at A minimum. Someone's mic is unmuted. Please mute it. And that is 6 mg. A means lowest point. A means lowest point. This is A. 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 Okay. So in A and B cases, velocity required at the lowermost point to complete the vertical circle is root 5 GR. Whereas in C, D and E, in C, D and E, object can't leave the vertical circle. Can't leave the vertical circle. Okay. You can see if it is connected to a rod, it will remain connected to that rod and it has to remain on the vertical circle. If a bead of mass m is inside a wire, then it will remain on the wire frame throughout its life. Correct? It cannot come out of the wire frame. So that is also bound to remain on the vertical circle. Similarly, when it is in a pipe, when a ball is in a pipe or when a mass is in a pipe, it is also bound to remain in the vertical circle. It cannot leave the vertical circle. Correct? So in C, D and E, object can't leave the vertical circle. So VA min, how much was that for this case? It was 4 GR. And TA min, obviously if it is 4 GR, then it will be 5 mg. So this was the scenario. Okay. Keep these things in your mind. Keep these things in your mind, everyone. All right. Remember these values. Okay. The questions which you will be getting from these topics will be very easy and you'll be easily able to solve them very easily. Okay. Okay. So let me give you a question. This is a mass M. Okay. This is R and it is string. It is R and it is string. If velocity at A point is given as VA is equal to root GR. Okay. VA is equal to root GR. So if mass M has been given, if mass M has been given velocity VA is equal to root GR at the lowest point, find maximum height. Find maximum height attained by the mass. Find maximum height attained by the mass. Please find. Suhas is saying R by 2. Chrisley is saying R by 2. Priyanshu is saying R by 2 with a question mark. Asmita is saying R by 2. Okay, everyone, please pay attention. So, suppose it goes up to here. First of all, listen very carefully. As you can see that VA is equal to root GR. It is less than root of 2GR, correct? That means it will not be able to cross this height, or it will not be able to rotate by angle 90 degree. Why? Because if velocity could have been root 2GR, it could have gone up to angle 90 degree, because in every quarter, remember, velocity is reduced by root 2GR within the root, correct? So this time velocity is even lesser than that. So if velocity is lesser than that, it will go somewhere in between. So let us find where it is. Let us find where it is. So obviously at that point velocity will become 0. So I am calling this point as A, this point as B. Let us apply MEC. So by MEC, between A and B. So PEA plus KEA is equal to PEB plus KEB. PEA plus KEA is equal to PEB plus KEB, and this angle is theta. This angle is theta. Okay. A point I am taking as reference line. So PEA will become 0. KEA half M into root GR whole square. PEB, let's say this height is H, so that will be mgh plus KEB 0, because velocity will become 0. Velocity will become 0. So let us solve it further. So GR by 2, because we have done the square, is equal to GH. So GG got cancelled. H is equal to R by 2. H is equal to R by 2. This is the answer. This is the answer. Okay. Okay, everyone. All right. So that's how you can solve questions related to motion in vertical circle. Now we are moving towards collision. Now we are moving towards collision. Collision. So you must have experienced collisions in life. Okay. We all have experienced collisions in life some or the other time. Suppose you are walking, and if you are not attentive, you collide with the wall. Okay. That is also a kind of collision. If you fall on the ground, that is also a kind of collision between you and ground. If you are riding a bike or driving a car, and if your vehicle touches some other object or collides with another object, that is a different kind of collision altogether. Okay. So what is common in all of these? That collision is a process in which impulsive forces act on the object for a very small interval of time. So collision is a process in which impulsive forces act on the object. Collision is a process in which impulsive forces act on the object for a small interval of time, small interval of time, and create a big impact. Big impact. Okay. Suppose sometimes you got angry and you went and slapped a person. That is also a kind of collision. Collision occurring between your palm and face of that person. Okay. Sometimes due to that impact, you can see that those fingers are marks of those fingers are there on the face of person. So that is impact of collision. Okay. This, as you are slapping with your hand, is the changes made will be temporary, like those impact or those marks will be gone after a few minutes. But if you do it by some stick or something, then that effect can remain for a longer time also. That person might get plaster also. Okay. The point which is to be noted is all of these are examples of collision. All of these. Correct? And while the collision is occurring, one object is exerting impulsive force on another object and vice versa. Both objects basically exert impulsive forces on each other. The one which has more tendency to get deformed gets more deformed. Okay. And the one which has higher strength, it gets lesser deformed, and you find lesser impact of collision on that object. Okay. All right. So before we talk about details of collision, let us talk about impulse. Impulse. So it's a basically vector quantity. So impulse, product of force and time. Product of force and time gives impulse. So I is equal to, in fact, I vector is equal to F vector into T. I vector is equal to F vector into T. Please note, impulse is equal to force into time. Impulse is equal to force into time. Okay. Let me give you a question based on this. A force of 50 Newton acts on an object of mass 10 kg for 5 seconds. Find impulse of force, or find impulse caused by the force. Please find. Solve it quickly, everyone. Solve it quickly. Solve it quickly. Suhas is saying 250 Newton seconds. Siddhi is saying 250. Crisel is saying 250. So I will be F into T. F is 50, T is 5, and that will be 250 Newton second. Okay. 250 Newton seconds. All right. Good. Now let us move further. Let us move further. Impulse is also defined as impulse is also defined as change in momentum. Change in momentum. So I vector is equal to delta p vector. I is equal to delta p vector. That means I is equal to p final vector minus p initial vector. I is equal to p final vector minus p initial vector. Okay. I is equal to p final vector minus p initial vector. Question. This is a wall and this is a ball. Mass is 5 kg, 20 meters per second. If ball collides with the wall, if ball collides with the wall and stops, find impulse, find impulse exerted by wall on ball. Please find. Please find. Okay. So people are saying, pay attention, that P initial of ball is equal to 5 into 20 is equal to 100 I cap. P final of ball is equal to 5 no into 0 is equal to 0. So delta P vector is equal to P final minus P initial 0 minus 100 I, and that will be minus 100 I kg meters per second. All right, and that is equal to impulse, because I is equal to delta P. I is equal to delta P. No, sign is fine. If you have given answer with proper magnitude, I am okay with it. Your answer is considered as correct. IPQ. IPQ means in the previous question. IPQ, if ball rebounds with same speed, if ball rebounds with same speed after collision, after collision, find impulse, find impulse exerted by wall, find impulse exerted by wall. Please find. Suhas has given the answer. Gauri also. Chirag also. Rakhi, Crisel, Pooja, Naushain, Samarth, Priyanshu, Asmita. Okay, everyone. So I am solving it here only. So P initial will be 100 I cap Correct. P final, because it is going in opposite direction. So that will be minus 100 I cap. Correct. So I is equal to delta P vector is equal to minus 100 I minus 100 I. That will be minus 200 I. That will be minus 200 I. So that is the answer. That is the answer. Okay, everyone. Okay. If you have any doubt, please feel free to ask. Please do not hesitate. Ask. Okay. Next question. Question. This is the ball. Okay. This is a ball. Okay. M is 5 kg. Velocity is 20 meters per second. And the ball goes and collides with the wall, and it goes like this. It goes like this. So if this angle is 53 degree, this angle is also 53 degree, and this is also 20 meter per second. Find impulse. Find, this is 20 meter per second, it is given. Impulse exerted by wall on ball. Please solve it quickly. People are saying 120. Okay. Everyone, please pay attention. I am considering this sign convention. Which one? This. This is x-axis. This is y-axis. Okay. Okay. Now pay attention. This, this angle will be 53 degree. Similarly, this is going like this. If this is 53, this will also be 53. So P initial vector is equal to 5 into 20 is 100. So 100 cos 53 I cap plus 100 sin 53 j cap. All right. So that can be written as 100 into 3 by 5 I cap plus 100 into 4 by 5 j cap. So P initial comes out to be 60 I cap plus 80 j cap. that is P initial, equation number 1. Now P final. So in P final, what you can see is this is again 100. So this will be 100 cos 53, and this direction will be 100 sine 53. So I am writing directly minus of 100 cos 53 I cap plus 100 sine 53 j cap, and that will be minus 60 I cap plus 80 j cap. Delta P vector, that will be I vector, is equal to P final minus P initial, and that will be minus 120 I cap kg meters per second. This is the answer. Okay, so if you have given 120, your answer is correct. All right, but you need to take care of directions also. You need to take care of directions also. How to take components of that, how to subtract, how to take plus minus, that all you need to take care. Okay, any doubt, any question? Good. Next point. Next, area of ft graph. Ft means force time. With time axis gives impulse caused by the force. Okay, area of ft graph with time axis gives impulse caused by force. So suppose this is time, this is force, and this is your graph, then your area, let's say this is t1, this is t2, so this area will be your impulse. So area is equal to impulse. Area is equal to impulse. All right. All right. Question? If force shown in graph, if force shown in graph acts on a mass 5 kg, if force shown in graph acts on mass 5 kg, find velocity of mass, at number 1 t is equal to 5 second, number 2 t is equal to 10 second, if initially mass was at rest. If initially mass was at rest. Samarth has become binary. Samarth has become digital actually. His answers have become binary. समर्थ से पूछा समर्थ खाना खाएगा, बोलता है 0. ओके. समर्थ वॉक के लिए जाएगा, बोलता है 1. ओके. Everyone please pay attention. So first of all, let us find impulse. So impulse during 0 to 5 seconds. I 0 to 5 is equal to I 0 to 5 is equal to 1 by 2 into base is 5 into height is 20. So 20 into 5 is 100 by 2 is 50 Newton seconds. Similarly, I impulse during 0 to 10 seconds. So I 0 to 10 is equal to 50 plus, because 50 is already there, how much will be area of this? So that is 5 into 20, and that will be 150. But be very clear, these are impulses. These are impulses. So I is equal to delta P is equal to m times V final minus V initial. So I is 50, that should be equal to m is 5 into V final, because V initial is 0. Okay, starting from rest. So that gives you V final at t is equal to 5 seconds as 10 meters per second. Okay. Now similarly, 150 is equal to m times V final minus V initial. So 150 is equal to m is 5 V final. So V final comes out to be 15 meters per second. 15 meters per second. How you are getting 30? How you are getting 30? People are getting answers as 30. Okay, okay. I divided it by 10. That's fine. So this will be 30. All right. Okay. So 10 meter per second and 30 meter per second. All right. But earlier people were giving different answers. Earlier they were giving answers of impulse, but the question asked was different. That is the beauty of answering. You give answer to what you feel comfortable rather than what was actually being asked in the question. That's nice. Correct. And if someone questions, you go and block the road. Why? Because we have numbers. Okay. Next question. This is T, this is F. This is half circle. It looks like basically. This is F naught. This is T naught. If initial velocity if initial velocity of an object of mass m is v naught, find its velocity at t is equal to t naught. Please find. Please find. Hmm. 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 Suhas is saying T naught pi plus mv naught by m. That's Suhas is saying. Chrisley is saying pi ft by 4m plus v. All right. Gargi is saying pi t naught plus 2m v naught by 2m. Hmm. Okay. Hmm. Hmm. Samarth is saying pi t by 4m plus vi. सब लोग ब्लफ मारने में लगे, सब के सब. Gauri is saying pi t naught plus 2m v naught upon 2m. Okay, enough time given, I guess. Pay attention. First of all, if you observe, this is f naught. This is f naught. And this side is anyway t naught. So basically, this is not a half circle as it looks like. What it can be? It can be an ellipse. It can be an ellipse. Okay. So this is an ellipse which I have drawn. On or for this ellipse, this is called major axis. This is called major axis and this is called minor axis. Okay. Okay. These distances basically from here to here it is 2a and from here to here it is 2b. So this distance is a and this distance is b. Okay. Just to tell you, area of ellipse area of ellipse. So A is equal to pi into A into B. A is equal to pi into A into B. Okay. Why we talked about this? Because we are going to use this data in our question. In our question. Now pay attention. Area is equal to impulse because area of FT graph gives impulse. And that will be pi. Acha, this is half of ellipse. So 1 by 2 into pi into A, it is F naught, into B, that is T naught by 2. So impulse comes out to be pi F naught T naught by 4. Impulse comes out to be pi F naught T naught by 4. पिक्चर अभी बाकी है. पिक्चर अभी बाकी है. समर्थ, don't try to change your answer. I am telling you. So I is nothing but mv final minus mv initial is equal to I, and that will be pi f naught t naught by 4. Now v initial is given as v naught. V initial is given as v naught. So m times v final will be mv naught plus pi f naught t naught by 4. So this will give us v final is equal to v v naught plus pi f naught t naught upon 4m. Okay, this is the answer today. This is the answer. How you can add f to your previous answer? How? Once you have submitted the OMR, you cannot do anything. Okay. How many of you got the correct answer? तुमको पिटाई कर करके मैं तुम्हारा टाइपो दूर कर दूंगा. So answer is Vf is equal to V naught plus pi F naught T naught upon 4m. No problem, Suhas, no problem. Okay, so keep that thing in mind. Keep formula of area of ellipse also. Okay, Ram. Okay. Now, if suppose force is variable, then how to calculate impulse? So impulse due to variable force. Impulse due to variable force. If force is variable, that means I is equal to f of t. No, f is equal to function of time. F is equal to function of time, then impulse due to the force. Then impulse due to the force I will be integration f dt, and limit will be from t1 to t2. That's how you calculate impulse due to variable force. That's how you calculate impulse due to variable force. Okay. Okay. Please note. Please note. Let me give you questions. Question: if force F is equal to t square plus 2t acts on an object during not during acts on an object, find impulse due to force during 0 to 5 seconds. Find impulse during 0 to 5 seconds. So I will be integration f dt is equal to integration t square plus 2t dt. The limit is from 0 to 5. So I will be integration 0 to 5 t square dt plus 2 integration t dt 0 to 5. So integration of t square dt will be t cube by 3 0 to 5 plus 2 times t square by 2 0 to 5. This 2 got cancelled. So what do we get is I is equal to 1 by 3 5 cube minus 0 cube plus 5 square minus 0 square. 5 cube by 3 is 125 by 3 plus 5 square is 25. 125 by 3 plus 25 becomes 200 by 3 Newton second. This is the answer, which becomes 66.67 or 66.667 or 66.66666667. Okay, as we are not talking about significant figures here, you have the freedom to go up to any value. All right. All right. So this is also the way to calculate impulse. This is also the way to calculate the impulse. Now we are going towards collision. So let us get back to the collision. So this is an object. This is another object. Okay. This is the object. This is the same object. Okay. This is the object and this is another object. Very nice. So let me call them as A and B, A and B, A and B. Initially they were moving with UA, UB. This is before collision. This is during collision. And this is after collision. Okay. Okay. So this will be VA and this will be VB. Now try to understand what is happening in this whole process. Initially, UA and UB have some velocities. Obviously, UA should be more than UB, then only A will go and collide with B. Otherwise, collision will not be possible. If UB is more than UA, A will not be able to reach to B and it will not be able to collide. If UA is equal to UB, then also the separation between A and B will not reduce and the collision will not happen. So for collision to happen between A and B, UA must be greater than UB. Alright, very nice. Now during collision what you can see is that A is colliding with B. A is colliding with B and obviously while the collision is taking place, A will exert force on B. A will exert force on B. Now due to action reaction, B will exert force on A also. Correct? B will exert force on A also. So if A is going to exert force on B towards right, if A is going to exert force on B towards right, B will exert force on E towards left. B will exert force on A towards left. So these are actually action reaction forces. These are actually action reaction forces, right? And pay attention. As force on B is acting in the direction of its motion, as force on B is acting in the direction of its motion, its speed will increase. Okay. And on A, force is acting opposite to the direction of motion, its speed will decrease. In other words, you can also say that as impulse on B is positive, so change in velocity of B will be positive. That means velocity will increase. As impulse on A is negative, change in velocity of A will be negative, hence speed of A will decrease. So after that, B will go away saying Tata and A will follow B with lesser velocity. Any doubt so far, anyone, in this description or explanation? Any doubt? Any doubt? Okay. Okay. Now, what to do to study this? So first of all, we are going to apply linear momentum conservation. We are going to apply linear momentum conservation. So by LMC, let me write it, linear momentum conservation. So what we can write is MAUA plus MB UB is equal to MA VA plus MB VB. Now you might ask, sir, how come we are able to apply linear momentum conservation? The reason is the force which is acting between A and B is their internal matter. If we take A plus B as system, then the force which A is exerting on B and B is exerting on A will be their internal matter. And if we want to interact or if we want to participate in that, they are not going to allow us. They are going to say, this is our internal matter, you stay out of it. I said, okay. So what we did, the initial total momentum of A and B is equal to final total momentum of A and B. Why? Because there is no external horizontal force acting on A plus B system. You can write this in words as there is no external horizontal force, acting on A plus B system. Okay. So as there is no external horizontal force acting on A plus B system, we could apply linear momentum conservation. Okay, everyone, just pay attention and see how things happen when we take A and B as separate objects. If we take A and B as separate objects, then how things happen for A and B. I am describing that also so that you can understand actually how things happen in collision. Okay, because we have limited time and we won't be able to complete the whole topic, so let me explain that part for you all. Okay, so if I is the impulse acting between A and B, if I is the impulse acting between A and B during collision, then, okay, now listen carefully. For A, so initially it was coming with MAUA, right? Now MAUA is in this direction. Impulse obviously will be in opposite direction because force is in opposite direction. So MAUA minus I is the impulse, and that will be equal to MAVA, equation number 2. Is there any doubt in this? Okay, pay attention everyone. Initial momentum plus impulse is equal to final momentum. Initial momentum plus impulse is equal to final momentum. All right, this is for A. Now for B, pay attention everyone. MBUB, this was initial momentum, correct? Now force on B is in direction of its momentum. Force on B is in direction of its momentum. So impulse will also be positive. So as impulse will be positive, so what we can write is MBUB plus I MBUB plus I is equal to MBVB. This should be equation number 3. This should be equation number 3. Pay attention to these two equations which we have written just now. Pay attention to these two equations which we have written just now. If you observe closely, your linear momentum conservation which was there, I have converted that into these two equations. Okay. If I add them, adding 2 and 3, adding 2 and 3. So what do we get? MAUA plus MBUB is equal to MAVA plus MBVB. This was your linear momentum conservation equation. How we got this? See, when we added these two, we took A and B as system. When we took A and B as system, their impulses got cancelled. Are you getting it? When we took A and B as system, their impulses got cancelled. Okay. So because of that, we got linear momentum conservation equation. If you want to apply for single object, you have to apply impulse momentum equation, or you can say impulse momentum theorem. And what is that impulse momentum theorem? That impulse is equal to change in momentum. Impulse is equal to change in momentum, or initial momentum plus impulse is equal to final momentum. And all this is in vector form. All this is in vector form. Initial momentum vector plus impulse vector is equal to final momentum vector. Okay, that's how you use these equations. Okay, when you apply LMC, that LMC comes through this process. What is the criteria to apply linear momentum conservation? That no external force should be acting on the system. Why we are saying no external force should be acting on the system? Because if external force is acting on the system, it will have its impulse. And we have to add that. Now here, when we have taken one impulse positive, one impulse negative, based on in which direction they are acting, when we took A and B both as system, those impulses got cancelled. And we got the final answer. So Srushti is saying, sir, so impulse is the internal force. Try to understand. Impulse is a different physical quantity. Force is a different physical quantity. Okay. Point number 1. Point number 2. Force creates impulse. When you get angry and you go and slap somebody, then you are exerting impulse on another person by the help of force. Okay. Or when you get angry and go and hit your head on wall, then also due to the force which you are exerting on wall, you are creating impulse on the wall. Effect might be completely, drastic and problematic also, but you do that. All right. So impulse is due to force. Is that clear? Now comes the internal force. No, it has nothing to do with internal or external. Impulse has nothing to do with internal or external. Impulse is due to force. If force is there, and force is acting for some time, it will create impulse. If force is there and the force is acting for some time, it will create impulse. Okay. To answer your question, let me give you question, all of you. Okay. Question. So this is an object which has been projected from ground. M is the mass, theta is the angle, u is the speed, this point is A, this point is O. Find impulse acting on the object. Find impulse acting on the object during OA. Please tell me quickly, everyone. Find impulse acting on the object during OA. Find impulse acting on the object during OA. Please find. Now there can be multiple ways to solve this question, everyone. There can be multiple ways. How I am going to solve it, let me tell you very clearly. Mg is the force which is acting on the object throughout its motion, and that is constant. That is constant. So I will be F into delta T. So F is mg minus j cap. F is mg minus j cap because it is downward, and T is u sine theta by g. Finished. Question is over. Question is over. Suhas, check your answer. So your answer will be GG got cancelled. So minus mu sine theta j cap. This is the answer. This is the answer of impulse. Okay. If you want to solve in a different way, then what you can do, you can write impulse at the beginning. You can write impulse momentum, sorry. You can write momentum at the beginning. You can write momentum at the A point, and then you can subtract. Then also you will get the answer. And in both the cases, in both ways, you will get the same answer. You will get the same answer. Understood, Srishti? Srishti, understood? Suhas, understood? Suhas? Rest of the people, everyone understood? So whenever you need to calculate impulse, there are multiple ways. Impulse is equal to force into time. Impulse is equal to change in momentum. Impulse is equal to area. So those are all the methods which you can use. All right. Okay. So that is enough for today. We'll study further in the next class.